Hello students and welcome to my channel Maths App. So we will study the solution of Laplace equation in this video. So before this, the last video also I've solved Laplace equation. So I told you that there are two cases. Case 1 was when the boundary conditions on the variable y are more, then we take the sign of y positive and we take the sign of x negative, right? So now let us see what is case number 2. So we have to solve the Laplace equation which satisfies the condition u0 comma y, ul comma y and ux comma 0 is equal to 0. So if we check the conditions, we have the first condition u0 comma y is equal to 0. That means from here, which variable is becoming 0? We are applying the condition on the variable x, right? So x at 0 is coming out to be 0. The second condition is ul comma y is equal to 0. So what does it imply? X again, when we put x as L, it is again becoming 0. And the third condition is x comma 0 is equal to 0. That means now the condition is being applied on y. So y at 0 is equal to 0. So if we check now, we have more conditions on the variable x rather than y, right? So these type of problems will come under case 2. And the fourth condition is given to us that we will be using towards the end of the problem, right? So how to solve this equation? We know that the Laplace equation is del square u by del x square plus del square u by del y square equal to 0. So from here, we assume that let u is equal to x into y, right? If u is equal to x into y, so del square u by del x square will become x double dash y and del square u by del y square will become x into y double dash, right? So let us put it back in the equation. So x double dash y plus x y double dash is equal to 0. So from here, we get x double dash by x is equal to minus y double dash by y. Now, where to keep this negative sign? So whichever variable has more number of zeros, we will keep that variable equal to positive, right? So here x has more number of variables equal to 0. So the conditions of x are more. So we will keep x positive and we will keep y negative. So let us put it equal to k. And now we discuss all the three cases of k when k takes value 0, when k is positive and when k is negative, right? So let us take up the first case when k is equal to 0. So when k is equal to 0, let us solve the first equation x double dash by x is equal to 0. So this would imply d square x is equal to 0. So this implies m square is equal to 0. So this implies m is equal to 0 comma 0. So what is x from here? X is c1 plus x times c2, right? If x is c1 plus x times c2, let's apply the conditions. The first condition is x at 0 is equal to 0. So this implies when you put x as 0, we will get c1 is equal to 0. So from here, x will come out to be x times c2, right? Now let us apply the second condition. The second condition is x at L is equal to 0. So this implies C2 into L is equal to 0. Now L is the length of the bar, so L cannot become 0. So this implies C2 is equal to 0. So that will imply your x becomes equal to 0. If x is equal to 0, then automatically u will become 0 and this will lead to a trivial solution, right? But are we interested in a trivial solution? No, right? So what we do, we move on to the second case, that is when k is positive. So when k is positive, we assume k as p square. So x double dash by x is equal to p square. So this implies x double dash minus p square into x is equal to 0. So this would imply d square minus p square into x is equal to 0. So from here, we get the algebraic equation m square minus p square is equal to 0. So m will come out to be plus minus p. If m is equal to plus minus p, so x will turn out to be c1 e raised to power px plus c2 e raised to power minus px, right? So now let us apply the first boundary condition, that x at 0 is equal to 0. So from here we will get 0 is equal to c1 plus c2. E raised to power 0 will become 1, right? So from here we get a relation that c2 is equal to minus c1. So x comes out to be c1 e raised to power px. c2 I'll put minus c1, so I can take out c1 common and I will get e to the power minus px, right? Now let us apply the second condition. X at L is equal to 0. If x at L is equal to 0, that means C1 e raised to power PL minus e raised to power minus PL is equal to 0. Now, obviously, this term is not equal to 0 because this is some value, right? So this implies C1 is equal to 0. If C1 is 0, that will imply that x is equal to 0, which again implies u is equal to 0. And this again leads to a trivial solution, right? So again, we are not interested in a trivial solution, right? So we take up the third case, that is when k is a positive negative number, that is k is equal to minus p square. So we have the condition x double dash by x is equal to minus p square. So we frame the equation x double dash plus p square into x is equal to 0. So this implies d square plus p square into x is equal to 0. So from here, the algebraic equation will be m square plus p square is equal to 0. So this implies what is m? M is equal to plus minus iota p. So from here, x turns out to be c1 cos px plus c2 sin px, right? Now, again, let's apply the first boundary condition, that is x at 0 is equal to 0. So we will get 0 is equal to c1 cos 0 is 1, C2 sin 0 will become 0. So this implies C1 is equal to 0. So x will turn out to be C2 sin Px, right? Now, let's apply the next boundary condition, that is x at L is equal to 0. So 0 is equal to C2 into sin PL. Now C2 cannot be 0 because if C2 becomes 0, then x will again become 0. So we will again get a trivial solution. So we don't want any more trivial solution. So this would imply that sin PL is equal to 0. If sin PL is equal to 0, which values of sin PL are 0? Sin n pi. So from here we get PL is equal to n pi. So that implies P is equal to n pi by L, right? If P is equal to n pi by L, what will our x become? X will become C2 sine n pi by L, n pi by L multiplied by, right? We will get it from this equation by putting P as n pi by L, right? So we got the value of x. Now we need to solve for y also, right? So I'm just writing the value of x here. So x is equal to C2 sine n pi by L into x. And now let us solve for y. So for y, the equation was minus y double dash by y is equal to minus p square. So you can clearly see that negative sign will get cancelled from both ends. And we will get our equation as y double dash minus p square into y is equal to 0. So we will have d dash square minus p square into y is equal to 0. So that would imply m square minus p square is equal to 0. So m will turn out to be plus minus p, right? So if m is plus minus p, this implies what is y? Y is c3 e raised to power py plus c4 e raised to power minus py, right? And then we can put p, the value of p, it will be e raised to power n pi by L into y plus C4 e raised to power minus n pi by L into y, right? Now, the third condition was on the variable y. So, y at 0 is equal to 0. So, this will imply 0 is equal to, let's put y equal to 0. So, we will get C3. E raised to power 0 is 1. So, we will get C3 plus C4, right? So, this implies C4 is equal to minus C3. So from here, y turns out to be C3 multiplied by e raised to power n pi by L into y minus e raised to power minus n pi by L into y, right? Now we also know that sine hyperbolic y is e raised to power y minus e raised to power minus y by 2. So this expression is something like this. So we can multiply by 2 and divide by 2. So I can write this expression as 2 times C3 sine hyperbolic, the angle is n pi by L into y, right? So x is this value and y is this value. So from here we can frame the value of u. U turns out to be C2, 2C2 into C3 sine hyperbolic n pi by L into y, right? Now for all linear values of n going from 1 to infinity, I can just name this as a constant Bn. So I can write u as summation n going from 1 to infinity Bn sine hyperbolic n pi by L into, right? Now what is the last condition given to us? The last condition that is given to us is u at x comma a is equal to sine n pi x by L, right? So let us put this. So we have sine n pi by x upon L is equal to summation n going from 1 to infinity Bn sine hyperbolic n pi by L into a, right? So there is just a minute. When I multiplied u, there is just a mistake here. Wait, let me correct it. Yeah, I missed out one term. So you can see that when I have multiplied u with x and y, I missed out the term sine n pi by L into x, right? Yeah. So u is this. So from here, when I make the summation for all values of n, I will get n equal to 1 to infinity Bn sine hyperbolic n pi by L into y multiplied by sine n pi by L into x, right? Now when we apply this condition, we will have multiplied by sine n pi by L into, right? So from here, when I see this is a constant now, right? If this is a constant, what is Bn then? Bn multiplied by sine hyperbolic. So this is your Fourier coefficient, right? Sine hyperbolic n pi by L into a. This will be equal to 2 by L integration 0 to L. The function is sine n pi L by x and also multiplied by sine n pi L by x. So it will become sine square n pi by L into x, right? So now let us do the integration here. I'm not left with any space here. So sine square can be written as 1 minus cos 2n pi by L into x, right? Sine square theta can be written as 1 minus cos 2 theta divided by 2. So this 2 and 1 by 2 will get cancelled, right? So integration from 0 to L. So it will become x minus cos integration is sine. So we have sine 2n pi by Lx divided by 2n pi by L integration from 0 to L. So the first term will lead L, and when I put L here, LL will get cancelled and I'll get sine of 2n pi, that will become 0. So the only term that is left from here is L, right? So when I put it back in this integration term, I will get 1 by L multiplied by L, which is equal to 1. So from here, what will be Bn equal to? Bn will be equal to 1 by sine hyperbolic n pi by L into A, right? So finally, what is my U? U will be summation n going from 1 to infinity. This was the expression. So I will put in the value of Bn, that will be sine hyperbolic n pi by L into A multiplied by sine hyperbolic n pi by L into Y multiplied by sine n pi by L into X, right? So the process is not difficult. There are certain more terms. So you have to take care while writing the terms, because it might happen that you miss out some of the terms, right? Otherwise, it's very simple, right? So that's all with the second order, the second case of Laplace. I hope you have understood it. And if you like the video, do hit the like button. And those of you who haven't subscribed my channel, do subscribe my channel to get the latest updated video. Thank you so much and have a nice day.